Hey everybody, and welcome back to another Nielsen Networking video. In this video, we are going to learn everything you need to know about Linux file permissions. Now, before you start complaining that you don't care about Linux permissions because all you want to do is perform penetration tests, let me tell you that understanding and managing file permissions in Linux is a lot more than just a system administrator's task. It's a key skill for ethical hacking. Why? Because understanding file permissions can not only prevent unauthorized access, but because misconfigured permissions can leave systems wide open to attacks. In this video, we are going to break down how to manage file permissions to not only secure your own system, but to also better understand how to identify and exploit vulnerabilities in penetration testing scenarios. Now, all that said, let's get to it and discover why it's essential that every ethical hacker, along with system administrators, should be able to understand and manage Linux file permissions. All right, and real quick, the two objectives of this video are to learn how to discover, understand, and manage permissions for Linux files and directories, and learn how to identify and correct misconfigured permissions that may be exposing the system to a vulnerability. All right, and to get started on our first objective, go ahead and open up a terminal and head over to the directory you want to use to discover the permissions. If you are going to be modifying permissions, I would suggest you create a directory to do that in. I did this here in Perm, so everything I'm going to be doing in this video is in a directory I created specific for this testing. I would not do this in a live production environment in the Etsy folder or other folders that you care about, because if you change permissions on a file and you're not sure what you did, you could end up locking yourself out and breaking your whole system, which would suck. So let's not do that. Go ahead and create a directory, throw some files in there and play along that way. Warning out of the way, we are going to move on with the most standard Linux command you've probably used a million times, which is going to be ls with a L flag, and hit enter. Now real quick, I don't want you to get hung up on the pretty colors over here on the right, because depending on the profile settings for your terminal, they could be different. They could be different on your Linux distribution. They could be different if you're not root versus a standard user. So don't get hung up on them, because honestly, they're just a quality of life enhancement that you don't even need. Actually, since we don't even need them, I went ahead and created a little script that we can use to follow along for this part of the video. That won't be a distraction, because I know some of you have low attention spans. So what we're going to do is we are now going to focus on what is important. And the first thing we need to know is these 10 characters here. The first character is either always going to be a D or a hyphen / dash, whatever you want to call it. And what do they mean? D is always going to mean a directory, and the dash is always going to mean a file. See, you don't need the blue to tell you it's a directory because it has a D in front of it, right? Got it. Cool. Second, the 9 characters following either the D or the dash are going to make or break your system security. Why is that? Because these are your permissions. Now, you're going to have an R, W, or an X, followed by an R, W, and an X, followed by an R, W, or an X for everything. Now, what does that mean? Obviously, the R, W, and X stand for read, write, and execute. Should have been an E, right? Execute. It looks cooler with an X, so let's be right. Let's be real. So we read, write, and execute. Now, read, write, and execute for the first 3 are going to be for the owner. This is the owner. Whenever you see the permissions followed by a number, this is the number of hard links to the file. Don't worry about that. Whenever you see this, this is going to be whoever owns the file. And the reason root is the owner of all of these files is because I created them as root. When you create a file, you become the owner by default. The next 3, as you can see down here, are going to be the group, which happens to be root, because root, anything created by root, unless you've modified it, is always going to be put in the root group. That's what you can see down here. We have the NN Kali user, which is my standard user, is the owner. So he has read and write, permissions to this folder, or this file, I should say. But it's also a member of the root group. So anyone who's a member of the root group would also have, would also have read and write permissions. And then the last 3 are going to be other. So other means everyone if you're a Windows person, or authenticated users if you're in the domain. or all users, whatever, it means everyone. This is the most dangerous of all the permissions you're looking at, because anyone who happens to get on your system here has access to whatever those permissions are for that file or directory. So you can see how in this configuration, if they have right permissions here, you can cause a lot of damage. Really, really, really important that you never leave that group set with permissions that are unnecessary. So that preaching out of the way, hopefully you have a pretty decent understanding. Permission classes, these are going to be user, owner, and group, which is, again, going to be user or owner. And then you're going to have group, and then you're going to have everyone else or other or world. I don't know why I put world there. I guess maybe I was thinking that anyone in the world would have permission here. So that is kind of the breakdown. And then you're going to have read, write, and execute. And then please don't forget to like and subscribe. I just put that there as a shameless plug. So that's kind of the permissions, what you're going to look for. But now, how can you modify these permissions? How can you correct misconfiguration so you don't get hacked? Good question, and we're going to do that next. All right, so you're probably wondering what the cha-cha-cha slide you just watched was about, right? So to help explain it, I created the cha-cha-cha script. The cha-cha-cha script is going to break down the 3 commands we're going to be using to set permissions in Linux. And guess what? They all start with ch. So rather than call them the ch-ch-ch or however you wanted to say that, I just decided we'd roll with cha-cha-cha because that sounds cooler. Trust me. So these are going to be the cha-cha-cha commands. And the first cha-cha-cha command is going to be cha mode or change mode because that's what it is short for. However you want to say it, doesn't matter as long as you know what it does, right? And what it does is it allows you to change read, write, and execute permissions on files and directories. And I'll show you this in a minute. The second cha command is going to be change owner or chone or whatever you want to call it. Whatever floats your boat, I don't really care. Again, as long as you know what it does. And this allows you to change the owner and the group of a file or a directory. Last one is change group. This is short for change group. It allows you to change the group of a file or a directory. Now, what does that mean? Well, let's take a closer look real quick, shall we? These are going to be where you would use change mode. You're allowed to change read, write, and execute, assuming you have permission to do that, of either the owner. Well, I'll show you this in a minute. But that's where you would use it, on these permissions right here. To change the owner, that change owner, you would use change owner to change root to, say, nnkali user. And then lastly, to change group, you would use the change group command to change this parameter right here. So I've changed this to users, and down here I change it to users as well, right? Hopefully you understand that. To take this a step further, we're going to actually break down each command individually. And we're going to start with change mode. So let's clear this up real quick. All right, and the chmod or change mode command is actually the most difficult of the 3 cha commands. If you were to simply type it in and hit enter, you would get denied and it's saying you're missing operators and other junk, right? It refers us to the help file or tells us to use the man page. We don't want to do that. We want to use the cool script I wrote. That's going to break it down and make it easier for you to understand. So let's go ahead and take a look at that. All right, when you use the change mode command, you are going to need to assign a class the permissions. These classes are going to be either user, which will be represented by a U, group, which will be a G, others, which will be an O. Or you could do all of them, which is an A, which means it's going to set the permission for user, group, and others all at the same time. Now you can combine, if you just wanted to do user and group permissions, you could just do U and G at the same time, or you could do others and users and on and on, whatever combination you wanted to do there. Then there's the operator. The operator is where you're either going to add or take away permissions from the permission classes. So you would say like user, add, and then lastly, permission, read, write, or execute. So that is how the command would be structured. And I'll show you that in about 2 seconds here, but you would start with a class, you would either add or take away, read or write or execute permissions, and then the file name. So let's clear up and take a look at how that works. All right, before we can change anything, we need to first list what we're looking at. All right, cool. So we are looking at this directory, and we'll start with this file right here, Kali. Pick that because I'm prejudiced and I like Kali. As we can see, Kali only has permissions to read and write for root. Remember, the first 3 are the user or owner class. We'll just go with the user because that's the class identifier, and that makes it easier. So this is the user. So right now, no one else has permission to do anything with this file. And we can verify that over here on a standard user. If we were to, well, let's make sure we're in the right directory. We are. Make this a little bigger so you can see. And let's just try to cat Callie. Permission denied. We can't delete Callie. We can't do anything to Callie. We have no rights on Callie. But let's say we wanted to give rights. So we went over here, we did chmod, and we're going to give it to the other class. So we're going to do an O, which is everyone else, which would include NN Callie user, and then we're going to add. So there's that plus operator. And now we are going to give it read only. We don't want to give it write or execute. And then all you need to do is put the name Callie, which is the file or directory name. So that's how the command would be structured. It would be change mode or chmod. Then it would be the class you want to add or subtract or equal the permissions to. And then this is the permission. And again, you could stack this. This could be OG or it could be RW. OG, it would be the original read-write Callie. So you could do that. You would hit enter. And then if we go over here, we should now be able to cat Callie, which we can. And just as quickly, we can come over here and we can take that away. And we come back over here and we're denied. So let's try one more. Let's clean this up right here and take a look. And let's see what we got here. All right, so I'm just gonna make this a little easier in my eyes, maybe yours too. Let's do SCO here because this looks interesting. So SCO has read and write for root, and then it has read for the group, which the group is users. Now, I'm assuming NN Callie user is a member of that group, but we can verify this by doing groups NN Callie user. And if you look, this will list all the groups. And if we scroll down here, we can see that NN Callie is in fact a member of that group. So NN Callie should have permission to read that file. So if we cat SCO, we can see it. And it says, have you ever heard of SCO Unix? Probably not, because most of you probably haven't. All right, cool. So what if we were to go back over here and let's take away permission for the group? So what we would do is we would do chmod and we would do group. We're doing group this time instead of other. And we would take away read permissions and we would take that away for SCO. So now if we look at it, SCO, it should be set like Callie, and it is. So now only root should have access to do anything to that file. Let's go back over here, cat SCO, and boom, you can see we're denied, which makes perfect sense, right? So let's try one more for fun. If I can clean this up, let's just make this bigger. All right, let's get a listing because I don't remember what's in here. And let's play with this as the final test subject here. So we can see that the owner or the user has read and write, and so does the group. The owner happens to be NN Callie user. And the group is root, which doesn't really matter because root can do whatever it wants. But for this video, it does matter because right now, NN Callie user is the owner of this file and has, if I can type, has read and write. So we should be able to modify this file. So if we were to cat Susie, we obviously can see it, and we should be able to actually go in and modify it. So Susie is sus, totally. And we can say, yes, it is, right? And we should be able to save it. But what is this down here? It's denying us, right? No, it's not. That is actually just telling you the permissions for the directory, not the file in the directory, which is really confusing, I know, which is why following the 3 cha-cha-cha commands, we're going to go over what read, write, and execute permissions actually grant you when you give them. But first we need to finish this. So let's just go ahead and try to write this, right? Write this right. Okay, so we're going to say X and yes, and it let us, and we can see that it is in there. Now, let's take a look at why we were getting that warning. So if we go up a level and we do an LSL and we look at perms here, we can see that the owner, which is root, has read, write, execute. We can see the group, read, write, execute. But look at everyone else, which we're a member of, because we're not the owner and we're not a member of root. We don't have write permissions, but we do have permissions to write to a file that was given permission inside the directory. But if we went back to perms and we try to touch one, create a file, we can't. We can only do it on existing files that we were given permission on. So if I didn't change this to make us an owner or a group or set the permissions where everyone had access to this, we wouldn't have been able to modify it. I know that's confusing, which is why we're going to go over it as soon as we get through the last 2 cha-cha-cha commands, which we're going to do right now. So let's get back to root. All right, the change owner command is really easy, a lot less complicated than the change mode command here. And to show you that, we are going to modify the permissions or the owner. We're going to change this to root. So what we're going to do is we're going to chown, and we're going to now put root. So we're going to change the class. So it's always the command followed by what you want to set it to, what class you want to change it to, and then just the file name. And this is SUSE. So now if we look at it, root, it's root. So root has all the rights or all the permissions. Now if you go over here and you cat SUSE, denied. What a bummer, right? Now to set this back, you could just go over here and instead of root, put it back to NN, NN Kali user, go back over here, now has permission. Now one other caveat before we move on to change group, you can actually change the group at the same time you're changing the owner with chown, you can't even think. So how you would do that, you would do chown again, and you would then do, let's say NN Kali and NN Kali again. But you got to put a colon, which I forgot. So you got to put a colon, and then you put so you're going to do chown, owner, group, file name. Go over here. We should be able to do whatever we want. We already had permission, right? Cool. You look over here, you can see NN Kali is in fact the owner, and its group is the group. So it has rights to do all that. Now, you want to take that away, you simply do the opposite of what you just did. Go over here, go root, colon, root. Go back over here, denied. Sad face for NN Kali user. Now change group. Let's say we wanted to change the group on SUSE to give NN Kali some permissions through the group. What we would do is we would do change group, NN Kali, SUSE. And we can see now that group is set there, and being that NN Kali is a member of the NN Kali user group, he should be able to cat SUSE, which he can. And that is the last two cha-cha-cha commands. Pretty straightforward. And yeah, that's it. So let's take a look now at exactly what these permissions you've been handing out all willy-nilly, read, write, and execute actually do when they're assigned to a file or a directory. All right, permissions in Linux mean a little bit different whether you are talking a file or a directory. So we're going to break it down like that, file then directory for each permission. So read permissions. If you have read permissions to a file, you will be able to view or open the contents of that file, meaning you'll be able to cat it. You could go in with Vim or Nano or gedit, whatever floats your boat. Now, if you had read permission to a directory, you'd be able to list the contents of the directory, meaning whatever files are in it. However, if for some reason you only had like execute rights to a directory, you'd be able to change directory into that directory, do an ls, and you'd see nada because you wouldn't have permission at the directory level to see the files inside that directory. Make sense? Let's go to read or write. You're just on read. If you have write permission on a file, it allows you to modify or change the file's contents. Without that permission, you cannot edit, append, or truncate the file. Technically, you could do all of that. You just wouldn't be able to save it. Now, if you have write permission on a directory, you can create, delete, or rename files within that directory. Without those permissions on a directory, you cannot add, remove, or rename files inside that directory. That's why in that example, I couldn't go and create new files in the directory. I didn't have permission to write to that directory, although I could execute and read. That's why I could ls and see things in there. And the final permission, execute, the dangerous, well, they're all dangerous in their own way, but the really dangerous one. This allows you to run a file as a program or a script if the file is an executable, meaning you have a shell script here, a Python script, whatever. If you have this permission, you'll be able to run it as an executable. Without this permission, you'll never be able to get it to run, but you can read it. You might be able to read it. On a directory, allows you to enter the directory. You can CD into it. This is really important. I just mentioned you could CD with this permission. Without this permission on a directory, you cannot navigate into it, even if you can list its contents. So let's say you had permission to list what was inside it, but you didn't have execute rights to even get to it. You wouldn't ever be able to even CD into it to do anything with it. All right, by this point in the video, you are probably considering yourself a Linux permission master, an expert, which is totally warranted based on the amazing content. I get that. But let's say hypothetically, to finish out the video, let's imagine we are on a virtual lab here. that was administered by someone less skilled than yourself. And they may have inadvertently made some permission mistakes on a few files. Let's go ahead and take a look at what threat that could create, or what risk, by doing that, by not fully understanding the permissions. So let's go ahead and do that. All right, so let's see what we have. Let's try to find those misconfigured files. So if we were to go into the like folder, which is a good segue for, if you're enjoying this video, I would love it if you would give me a like. I would like a like. Let's look what we have inside this directory. So if we do an LSL here, we can see we have a right and a wrong file. I'm assuming they were named that way because one is set up correctly. And look, what do you know? It is. It's set up using the default, which is called the UMask, which we will cover right after this section in the bonus section. It is set up. This is kind of a template when you create a new file and you can modify this. These are the default permissions it's going to give it. But this guy down here, the wrong one, this looks totally wrong, right? It has read, write, execute for all the classes. That's a no-no. So being that we have at least permission to read this, let's see what we do when we go, right, well done. Okay, cool. So that file is good. But what happens when we cat wrong? It says hello world, but it's given an echo. Oh, that's because it's executable. So what if we were to execute this? It executes hello world. But what if we were to go in here and do nano wrong? And again, we're getting this warning here, but we know that doesn't pertain to us because that's just a directory. We might not be able to create a new file in this directory, but we certainly can modify this one because it has every permission under the moon. So let's say we wanted to do echo hello root, right? We save it, we go back and execute it, and boom, it's there. Now, obviously, this is a hypothetical situation. But what if this were actually a production environment and instead of hello root, you know, they decided to do something like modify other files or delete things or, you know, create programs that run in the background, things like that. That could be ugly, right? That is correct. And that is why this is set up wrong. So that is one problem. Now, how can we fix that? Well, you could obviously start by doing, you know your chmod command. And we could do it a lot of ways, but let's go crazy here and use the all class. We haven't used that yet, right? We've used user, group, and others, but not all. And let's go ahead and just take away execute. Oh, you need the file name. That is important. Oh, and you need to be the right user to do it. I forgot I am not root, so I cannot even do that, but root can. So we're gonna go ahead and do that again, and we're gonna do it with root. Now, if we go over here and we try to execute that, we are denied. So just like that, we have saved the day, coming in here, cleaning up that noobs, whoever set that up, those permissions. And now you can see this is actually a much safer file. Sure, they could still go in and write things to it, but it's much safer than it was before with just one command. So let's go ahead, let's continue on in IntelliUser user and take a look at another misconfiguration. If I could type, I think I'm a misconfiguration right now. All right, I'm back in the perms directory. Let's go ahead and see. Let's go ahead and head to this subscribe directory. And what a great time to ask you that. If you're enjoying the content and you don't want to miss out on future content, please subscribe to the channel so you don't miss anything. I won't even bill you for it. So let's go ahead and see what we have in here. Ooh, that looks nefarious. We have a hack me directory that, it has all these permissions. That seems not normal. Let's go ahead and see what's in it, because what else would we do when we find something that's not normal? We have to investigate it, right? So we go in here and let's do another one. Oh my goodness, we have some that are red. What the heck does that mean? And what does L mean? Well, I forgot to mention at the beginning, there are other types. I may have misspoken and said there were only, the only ones that you needed to worry about, maybe is what I meant to say, were the hyphen in the directory. Technically, you should know about the links, and there's a couple other like block devices, character devices that are going to be, the block devices are going to be your hardware. But anyway, for the most part, I guess I should have said you're going to have directory for D, you're going to have a hyphen for files, and an L for links. So these are actually links that look like they're owned by root, but the other or everyone else group has read, write, and execute. So we got everything we need, right? But they're pointing to this actual file, read, shadow, and got root. That seems strange, but we're just a standard user. What could we actually do? But let's just try to execute one of these, shall we? Let's try to execute root for me. See what happens. Oh my goodness, what is this? Who am I? Oh my God, I'm root. But how am I root? I didn't put in a password to become root. How did that happen? What? What? Okay, that's strange. I wanted to get out of there. I was a little scared. What else gotta we? Let's see what read shadow does. Oh my God, this is the shadow file? The dude's hash is here? The dude's gonna be pissed that we just shown his hash all over YouTube right there. Oh my God, what if it gets like someone knows how to use Jack the Ripper, which if you don't know how, you should look at my last video. But imagine that. Let's get this off the screen. Oh my God, we just publicly gave all that information away. This is not good. So what exactly is going on here? Well, what's going on, and to better illustrate the problem, all joking aside, because this actually isn't a funny matter, you can see these links are pointing, well, you can't really see, they're pointing to the user local bin, right? So root conveniently is already located there. Now, if we do an ls, what do we get here? We have permissions that have an S in them. Now, what does that mean? Stupid? No, what it really means is set user ID. Now, what this does is it gives anyone that has permission to run the file, which we actually had, because look, everyone has permission to execute it. It will run as the root user. Now, I don't know what this program is. If we do cat got root, I can't even tell what that's doing here. But whatever it's doing, it was giving root to that NNCali user, which is not what we want. Definitely not. If they wanted root, they should go through su or sudo, right? So this is really bad. So how are we going to fix this? And you're going to fix it by doing the chmod, and you're going to do the -s, and we're going to get rid of that for got root and for read shadow. And that takes away the S, but look, it still leaves the executable. But is that going to still be a problem? I mean, technically, yeah, we'd want to fix that. But will that fix the main problem here with this configuration that is giving NNCali user access to root? Let's see. So if we do root again, ooh, we still got a prompt, but oh goodness, we're not root. Thank goodness. And let's get out of here. And what happens if we do root? Actually, read shadow, permission denied. All right. So why is that happening? It's happening because these are, when you do +S, which is set user ID 4000, you've probably heard of that. Those give these files to run as the owner, and the owner was root. So when this was executed, whatever this program's doing, and unfortunately I can't show you that, it was actually running as root. And when it did that, for whatever reason, maybe it did a sudo or a su in the background, it allowed that to happen, open up a shell for my NNCali user to run as root. But now that it's not set to run as root, even though it's owned by root, it doesn't even have permission to do the command, whatever it's doing. So we're safe. But you see how dangerous it can be just having one misconfigured file or program out there. It could create a huge security risk. I mean, there's nothing worse than root on a Linux system, right? So right there was as bad as it gets. But thankfully, you're able to take care of that by just getting rid of that set user ID. And what the set user ID does, once again, is has that program. It could be, you could set this as a normal user and it would run as an NNCali user. So maybe I wanted to do that for some other reason. I don't know why, or you had a system or a service account, you wanted it to do that. But don't do that for root. There's no real reason for you ever to do that as root. Well, there might be, but just in a security standpoint, don't do that. So anyway, with that said, those are the two misconfigurations I wanted to show you, hypothetically. But let's finalize the video here with the bonus round, which we're going to actually show you a couple things you can do with chmod that we didn't cover before. So let me go ahead and go up here, clear out of here, and real quick, actually, let me just mention one thing real quick. There's something known as, before we get to octal notation, there's something known as UMask in Linux and Unix. And what that does is, think of it as your basic template for when you create a new file or a directory. So as you can see, test is a new file I created, and it came with standard permissions, which were read write for the user or the owner, and read for both the group and everyone else. And if I were to create a directory, it has a little bit different permissions because the people have to be able to change directory into it. So it's given the execute right as well. But to view your UMask, you just type in UMask. And you can actually modify your UMask to modify the default permissions that are given when you create a new file or a folder. I'm not really going to go into that here, but I did want to make that you aware of it. It's really simple to do. You could just literally Google UMask, but being that this is a 30-minute video, I don't want to really go off the deep end into that right now. So we're going to end it with the final script of the video, which is going to be the end script. And this is going to explain something known as octal notations. And that's interesting. Apparently we're not going to do it. We're actually, you know what, we're just going to cat it. But let's cat it when it's pretty. So let's just cat end. All right, this is the end. Now what I'm talking about here is in Linux, you can actually, instead of doing chmod and doing plus this, minus that, you can actually just use numbers. And I know that might not make a lot of sense, and we're not going to go crazy into it because this is a whole nother 10 minutes of a video, but I did want to explain that you can do something called octal notation, which you would use chmod and then a series of numbers that would give these permissions. So if I were to do chmod 777, that would give every single directory read, write, and execute. You've probably seen this on other things. And if I did 766, that would give 7 permissions, which would be rewrite and execute, followed by 6 for the group and other. So you can see what we get there. I know this is confusing. That's why I saved it to the end. But here are some examples I wrote up for you. So if you did 755, right? The owner is going to get read, write, and execute 7, but the group's going to get read and execute, and others are going to get read and execute. 644, owner would get read and write, yada, yada, yada. You can read all that, right? Cool. I just wanted to let you know that you can do that too, because I don't want someone in the video to go, well, there's other ways to do chmod or change mod. I know, but I didn't want to take forever to explain that. But hopefully take a screenshot of this. This kind of breaks it all down for you nicely. And then here's a couple examples for you as well. Maybe I'll even throw it in the description if you ask in the chat or the comments. So anyway, with that said, I think we are going to call it a day, an end of the video with the end little script there. And I hope you learned something. Permissions are critically important. They're not just for system administrators. They're also for you penetration testing people looking for vulnerabilities. Misconfigurations are just as bad as having outdated software. So that said, if you've enjoyed this video, please don't hesitate to like, subscribe, ring the bell, tell your friends, tell your mom, your grandma, everyone. I would greatly appreciate it. With that said, you have a great rest of the day and year and decade, whatever, century. Talk to you later. Bye.